Hello everyone, my name is Sean, and this is my project, New Applications of Thermoelectric Chips to Create Sustainable Green Energy. My goal is to cool down my CPU based on the Seebeck effect by conducting a hot and cold side between the TEC chip that I'm using to create an energy source for my heat dissipation device. So over here, these are my methods. And the flowchart starts from disassemble the PC to examine interior, initial data getting, see the highest possible CPU temperature, also the micromotor speeds, and also the TC energy conversion rate. Then, following to the connection test, the TC chips connected with the micromotors. Then the module that will be placed on the CPU, heat tunnel design, then conclude and discuss about the results, and then extend research and future development. And over here are the devices that I used, starting from the computer, the original radiation devices, the CPU, and also heat seekers for the main testing. And over here are the micromotors, batteries, speed test module, old, and also the stroboscope that I'm using for my current, all of my speed tests. These are the parts that I use to speed test my micromotors. And down here, there are thermal gel, thermal pads, and also radiators that I self-created using 3D printing, and also a breadboard for the main experiment that I'm concluding right now. The whole system is based on these items. Alright, over here, the experimental results. After disassembling the CPU and also all of the computer devices, the highest temperature that I detected is 70.7 degrees Celsius, or even higher because it has a fail-safe mechanism to stop the CPU from overheating itself. The next, the average speed of the 820 micromotor is the highest above all of the micromotors that I selected. 3. After testing the voltage and current generated by the CPU and also TEC chip, the highest voltage created is 132.3 millivolts and 9.4 milliamps as a current. And then the TEC chip can create enough power to drive the micromotor. Then it will stop due to insufficient power that is drained off the TEC chips, which is used on the micromotor to blow the fan. And as we can see in this chart over here, the longer the fins are, the more efficient it can dissipate heat. So right over here, there's a long one and also a short one as the fin size. Alright, so over here, conclusion. Through this experiment, I can see that the TEC chips can actually help our heat dissipation system. Due to there are some energy conversion rate problems, it's not efficient enough. So right now I'm creating another system to see if I can store power or even improve its energy conversion rate. I hope this can also solve my problem of all the nagging radiators that I meet and you guys meet. And over here are my references that I used for this experiment. So back to here, why am I using this as a system as a heat dissipation device? First of all, the TEC chip Seebeck effect creates power on its own due to heat and cold differences between the two sides. So it doesn't need an external power source, different from all the market radiators and also heat dissipation devices right now. So on the future, I'm planning to use this on, well, based off the CPU heat temperature that can drop. Then I'm going to use them on wearable devices, and also, in the future, autonomous cars, electric cars, or even data centers and also server rooms. I thank you all for listening, and this is the end of my presentation.